Let us see, this is another very easy problem, probably one of the CBSE level problems that you will see in IIT-JEE 2012. It says a biconvex lens is formed with two thin plano-convex lenses as shown in the figure. Refractive index N of the first lens is 1.5. This is having a refractive index of 1.5. And that of the second lens is 1.2. This is 1.2. Both the curved surfaces are of the same radius of curvature are equal to 14. This is given to us. For this biconvex lens, for an object distance of 40 centimeter, that means u is equals to minus 40. Right? U is equals to minus 40. What is the image distance? Right? So we have to calculate. Now for a lens, if we consider this as a lens combination, 1 upon v minus 1 upon u is equals to 1 upon f. This is the formula. Right? Now for calculating v, we have to also calculate f. Now these are basically two lenses, a combination of two lenses. So let us first of all calculate the focal length of the first lens, which is given by the formula mu minus 1 upon r1 minus 1 upon r2. Right, this is the formula. So which will be equal to 1.5 minus 1 radius of the first surface. This is given to us 14, and since it is a plano-convex lens, other will be a plane. That means r2 will be infinite. This will be equals to 0.5 by 14. This is 1 upon f1. This is our first lens. Now for the second lens, 1 upon f2, again the formula, same formula should be applied. 1 upon r1 minus 1 upon r2. Right. So this will be equal to, now the refractive index for the second lens is 1.2. That means 1.2 minus 1. Now what is r1? Since now it is first of all plane, so that means 1 upon infinity minus 1 upon r2. R2 is the radius of this lens, right? 1 upon 14 minus 1 upon 14, because this lens is facing on the left hand side. So this will be equals to 0.2 by 14, right? Now for the combination of these two focal lengths, 1 upon f, which is the common, this is given by 1 upon f1 plus 1 upon f2, which will be equals to 0.7 divided by 14, right? Or we can say that f would be equals to 14 divided by of 0.7, which will be equals to 20 centimeter, right? We can also solve this by putting, we can solve this question by putting f and u in this formula, or otherwise it can be, solved even without seeing the problem. What we can see is the focal length is this much, 20 centimeter. That means the center of curvature C would be equal to at what distance? 40 centimeter, right? Center of curvature is 20 centimeter, which is equals to 2f. Now we know that when we place an object at a distance of 40 centimeter from it, image is also formed at 40 centimeter, right? You know what you can do is you can put this values in this and you will get the same answer. I'm again repeating it. If u is equals to minus 40, if u is 40, then v also becomes 40, because whenever we place an object on the center of curvature, the image is also formed at the center of curvature. This is true in the case of lenses also, and also in the case of mirrors also, right? So the answer would be 40 centimeter, and this was another easy problem.